In this lecture video, we'll solve a problem to understand how to obtain transfer function from a electrical circuit. Find the transfer function for the electrical network shown below. So this is the electrical network which is given to us. It consists of a series combination of resistor R1, R2 and a capacitor. The output voltage V0 is extracted across a series combination of R2 and C. The input voltage is given to the circuit as well. So we already know that the basic definition of transfer function. The Laplace transform of output to the Laplace transform of input gives us transfer function. So V0 of S divided by Vi of S gives us transfer function. So in order to obtain transfer function, we need to first convert this electrical network into S domain. The S domain network is as shown. Vi of S, V0 of S, R1 and R2, there will be no change in the element. There will be no change in it. Whereas in place of capacitor, we'll be writing it as 1 by CS in Laplace domain. The output voltage V0 of S is given as I into Z. Z is nothing but impedance with respect to this particular section. So if we observe R2 and this capacitor, resistor and capacitor are connected in series. Hence, V0 of S will be equal to Z into I of S, impedance into current. The impedance value was R2 plus 1 divided by C into S. So V0 of S is equal to I of S into R2 plus 1 by C into S. So when we simplify that, we'll get as V0 of S is equal to I of S into R2 into CS plus 1 divided by CS. Let us consider that as equation number 1. Now we have obtained the voltage equation with respect to output. Similarly, let us try to obtain the voltage equation with respect to input. To obtain that, let me consider the same circuit and let me apply KVL to this particular network. We already know when we are applying KVL, first we need to write the sign convention. The terminal of the element where the current is entering is always taken as positive, and the terminal of the element where the current is leaving is always taken as negative. We have considered that the current is traveling in clockwise direction out here. So this particular terminal current is entering, so it is positive. This particular terminal current is leaving, so it is negative. Same convention is applied everywhere. Next, when we analyze a circuit in clockwise direction, negative to positive, there is a rise in potential, so that should be taken as positive. So plus Vi into S. Positive to negative, there is a drop in potential, so the voltage should be taken as negative, minus R1 into I of S. Positive to negative, again there is a drop in potential, that should again be taken as negative, minus R2 into I of S. Positive to negative, again there is a drop in potential, minus 1 by CS into IS equals 0. We have sent this minus R1 IS minus R2 IS minus 1 by CS IS towards the right hand side. It becomes positive. We have taken I of S common. So when we simplify that, we'll get this equation. Let us consider this as equation number 2, which is with respect to input Vi of S. Now, we already know that the transfer function is Laplace transform of output to the Laplace transform of input. So when we substitute or when we divide equation number 1 with equation number 2, we'll get transfer function equals I of S into R2 CS plus 1 divided by CS divided by I of S into R1 CS plus R2 CS plus 1 divided by CS. CS and CS gets cancelled. I of S and I of S will get cancelled. So we'll be left out with transfer function is equal to R2 into CS plus 1 divided by R1 CS plus R2 CS plus 1, or transfer function is equal to R2 CS plus 1 divided by, we have taken CS common over here, so it becomes R1 plus R2 plus 1. So this is the procedure which we follow to obtain transfer function or to extract transfer function from a given electrical network. I hope that you have understood this video lecture. Thank you.